Hi friends, welcome to Kraku's video series. I'm Sayali Ma'am. I'm one of the co-founders of Kraku and an alumna of AMNB. In these video series, we'll be solving DILR sets from CAT 2017. We'll be trying to show a generalized approach for solving these kinds of sets so that students who are seeing these and are preparing for CAT 2018 know exactly how to approach CAT DILR as such. So let's get started. We have already covered the first 6 sets from the first lot. So please do check out those videos. In this particular video, we'll be solving the 7th and the final DILR set. So let's start with the 7th set in DILR. The 7th set is a new airlines company is planning to start operations in a country. The country has identified 10 different cities which they plan to connect through their network to start with. The flight duration between any pair of cities will be less than 1 hour. To start operations, the company has to decide on a daily schedule. The underlying principle that they are working on is as follows. Any person staying in any of these 10 cities should be able to make a trip to any other city in the morning and should be able to return by the evening of the same day. So this is the basic setup that there are 10 cities and anybody should be able to make a trip in the morning and should be able to come back in the same day in the evening. So if the underlying principle is to be satisfied in such a way that the journey between any 2 cities can be performed using only direct flights, then the minimum number of direct flights to be scheduled is this. What? So let's first understand what the question is asking. So there are 10 cities and you should be able to go, like suppose there are 2 cities A and B. So you should be able to go from A to B in the morning and go from B to A in the evening. But you should also be able to go from B to A in the morning and come back from A to B in the evening. So between any 2 cities, these are the morning flights, these are the evening flights. So between any 2 cities, you will need total of 4 flights. 2 in the morning, 1 from A to B and 1 from B to A, and 1 in the evening, 1 from B to A and the other from A to B. So between any 2 pairs of cities, any pair of 2 cities, you need 4 flights. Now if there are 10 cities, how many such pairs will be there? So number of pairs will be 10C2 essentially. That is 10 cities picking 2 at a time, you will get 10C2 pairs like that. And for each pair you need 4 flights. So you get the total number of flights required as 10C2 into 4. So this will be equal to 10 into 9 divided by 2 into 4, that is essentially 10 into 9 into 2, that is 180 flights. So you would need 180 flights for you to satisfy this underlying principle. So now let's go on to the next question. Suppose 3 of the 10 cities are to be developed as hubs. A hub is a city which is connected with every other city by direct flights each way, both in the morning as well as in the evening. The only direct flights which will be scheduled are originating or terminating in one of the hubs. Then the minimum number of direct flights that need to be scheduled so that the underlying principle of the airline to serve all the 10 cities is met without visiting more than one hub during a trip is. So essentially instead of having all the 10 cities connected to each other, you will have all 7 cities connected to a particular hub. So suppose this is hub A, then it will have 7 connections essentially, this 5, 6 and 7, and these are the smaller this, and it will also be connected to the other 2 hubs, that is A, B and C, and all of B and C will also be connected to the same 7 cities. So let's first consider the hub and the cities. So for the hub to be connected to the remaining 7 cities, so how many connections that would be? So that would be 7 connections, and between each connection, as I said, between any 2 pairs of cities you would need 4 flights. 2 in the morning, so suppose this is like X, so you would need A to X in the morning. So in the morning you would need A to X as well as X to A, and in the evening you would need X to A and A to X. Only then can you start off at a city and end up in the another city and like start in the city and go to another city and come back in the evening. Only if all 4 flights are present. So as far as A is concerned, it would need 4 flights per each of these 7 connections. So for each of the hubs, you would have, for one hub, you would have 7 connections and each of these will require 4 flights. So for 3 hubs, you will have 3 into 7 into 4. So this is equal to, this is 21 into 4, that is 84 flights. Now you would need interconnection between these hubs as well. So there are 3 hubs. So the number of connections between the 3 hubs is essentially 3C2, and the number of flights per connection is 4. So that is 3C2 into 4, that is essentially 3 into 4, that is equal to 12. So the total number of flights that are needed are 84 plus 12, that is 96 flights. So the answer to this question is 96 flights. Now let's go on to the next question. Suppose the 10 cities are divided into 4 distinct groups, G1, G2, G4, G3, G4 having 3, 3, 2, 2 and 2 respectively, such that and G1 consists of A, B and C. Further, suppose that direct flights are allowed only between 2 cities satisfying the following thing. Both cities are in G1, between A and any city in G2, between B and any city in G3, between C and any city in G4. Then the minimum number of direct flights that satisfy the given principle is. So let's figure out how many connections are there. For each connection we'll need 4 flights. So all cities in G1 have to be interconnected. So there are 3 cities in G1. So essentially that will be 3C2 into 4. This is equal to 3 into 4, that is 12 flights. Now between A and any city in G2. So between A, there are 3 cities in G2. So between A and any city in G2 there will be 3 connections essentially. Start between A and any city. So for each of these 3 connections we need 4 flights. So this is equal to 12 flights. Now between B and any city in G3, there are 2 cities in G3. So between B and the 2 cities in G3 we'll have 2 connections, and for each of these 2 connections we'll need 4 flights. So that will be 8. And for between C and any city in G4, there are 2 cities in G4, so there will be 2 connections, and 2 connections into 4, that is 8. So the total number of flights will be 8 plus 8 plus 12, that is 28. 28 plus 12, that is 40 flights. So the answer is the number of direct flights, minimum number of direct flights would be 40 flights. Now let's go on to the next question. Suppose the 10 cities are divided into 4 distinct groups, so essentially the same thing as such. However, due to operational difficulties at A, it was later decided that only the flights that would operate at A would be those to and from B. G2 would have to be assigned to either G3 or to G4. What would be the maximum reduction in the number of flights as compared to the situation before the operational difficulties arose? Now, so if you see that what happened with G2 and G3, so for each city in G2, we had to add 4 flights essentially. So if we transfer all these cities that are there in G2 to G3 or G4, there won't be any change as such, because you would have to add 4 flights to B, from B or from C. So there would be no difference as a result of that. So whether you put all of these G2 cities in G2 to G3 or to G4, for each city in G2, you would have to add 4 flights again. So those flights will be compensated as B to that city or C to that city. The only change that will happen if you don't allow any flight from A1 is if you don't, if you allow only flight from A to B, that means you are not allowing. Earlier you had 3C2 into 4, right? Only this part will change, because all the cities of G2 will be added to G3 and G4. This part will remain the same, this part will remain the same. These 12 flights will go to one of these 2. So essentially the 8 plus 8 plus 12 will remain unchanged. The only thing that will change is this 3C2 into 4. So instead of 3C2 into 4, now you would lose the connection between A and C. So only 2 connections will exist between A to B, and A and B, and B and C. So now this will be essentially 2 connections into 4, that is 8. Earlier it was 3C2 into 4, that is 12. So the change would be 12 minus 8, that is 4. Another way to think of it is that if because of operational difficulties at A, it is only allowed to send flights to B, and G2 and G3, G2 is shifted to either G3 or G4. The only change is the flight between A and C. If you are just stopping the flights between A and C, and there were 4 flights between A and C. So the maximum reduction in the number of direct flights as compared to the situation before would be 4 flights. So the answer is 4. So this is how we solve this set. This wasn't a tricky set, a difficult set, but it was slightly tricky. I know a lot of students faltered here because they did not consider the fact that there would have to be 2 flights, that one in the morning there had to be like A to B and B to A and vice versa. So many students just counted this as that between each connection they'd need 2 flights, and then they messed up royally, because as you saw in each this we had to multiply by 4. If you multiplied by 2, you'd get the entire set wrong. So this set was not difficult as such, but it was tricky. If you didn't read the question properly, you would get the entire set wrong and you would lose a lot of marks. So always make sure that you read this. As you saw, we didn't take a whole lot of time to solve these kind of questions. So always make sure that the first caselet that is given, the first introductory paragraph, that you read it very carefully. Each sentence has an implication. When the sentence says that somebody should be able to go to and from, that also means that if A can go to B and come back in the evening, somebody has to be able to go from B to A in the morning and come back in the evening. Always think carefully when you are reading the initial paragraph. So as you saw, this was not a difficult set if you did not get that part wrong. So let's go on to the next question. 4 cars need to travel from Akala to Bakala. 2 routes are available, one via Mamur and other via Nanur. The roads from A to M and from N to B are both short and narrow. In each case, one car takes 6 minutes to cover the distance, and each additional car increases the travel time per car by 3 minutes because of congestion. For example, if 2 cars drive from A to M, each car takes 9 minutes. On the road from A to N, one car takes 20 minutes and each additional car increases the travel time per car by 1 minute. On the road from M to B, one car takes 20 minutes and each additional car increases the travel time by 0.9 minutes. The police department orders each car to take a particular route in such a manner that it is not possible for any car to reduce its time by not following the orders while the other cars are following the order. So the question here is how many cars would be asked to take this route, that is A and B, by the police department. So first let's try to draw the network diagram for this. So the network diagram for this will be like this, that is A, M, B and A, N, B, and this is 6 minutes plus 3 minutes per extra car. So if the number of cars going is X, so it will be 6 plus X minus times 3. So if 2 cars go, it will be 2 minus 1, that is 1 into 3, so it will be 9 minutes. If 3 cars go, that will be 3 minus 1, that is 2 into 3, so that is 6 minutes, 6 plus 6, that will be 12 minutes. So and so on. We see that the same thing is given for the other side also, so that is N to B. So we'll write the same equation, 6 plus X minus 1 times 3. Now let's see the first part. On the road from A to N takes 20 minutes and 1 additional minutes per extra car travel. So that is 20 plus X minus 1 times 1. So just X minus 1. So we'll say that if X cars travel from A to N, the time taken by each of them will be 20 plus X minus 1. And from M to B, it is 20 minutes per, and travel time increases per car by 0.9 minutes. So that would be 20 plus X minus 1 times 0.9. So this is the network diagram essentially. So now let's try to figure out. So we have been told that each of them travels in such a way, the police department orders each car to take a particular route in such a way that it is not possible for a car to reduce its travel time by not following the order. So let's consider this again. So we have AMB and ANB. Now like suppose that the number of cars, if all 4 cars go from A and B and 0 cars go from A and B. So in this particular extreme case, this will be 6 plus X minus 1 times 3. So X is 4. So 6 plus 3 into 3, that is 9. So this will be 15 minutes plus this will be 4 minus 1, that is 3. 3 into 0.9, that is 2.7. 20 plus 2.7 is 22.7. In this case, this value will be equal to 37.7. Let's calculate the same thing for this is 0, so that is not this. So all 4 cars will take 37.7 minutes. Now suppose it is 3, 1. In this case, this will be 3 minus 1, that is 2. 2 times 3, that is 6. So this will be 12. 12 plus this is 2, so that is 1.8. So that is 12 plus 21.8. So 12 plus 21.8. So this is equal to 33.8. And this one car will take, it will take 20 plus 6, that is 26 minutes. Now if you were in these guys' position, so all cars went from A and B and they took 37.7 minutes. But if one of them switched to A and B, they would go through at 26 minutes. So they would definitely not follow the police orders and they would go through A and B. So this is definitely not the case. This is not how many cars are going through AMB and A and B. Now let's consider the case where there are 2 and 2 cars. If it's 2 and 2 cars, now we'll see that this is 2 minus 1 times this, so 6, this is 9 plus 2 minus 1 is 0.9, so that is 20.9. So this is 29.9. And this part is 1, so this is 21 plus 9, so that is 30. So this value for 2 and 2 is 29.9 and 30. Now let's consider the other case. If it is 1, 3. If it's 1, 3, then these values will be, this is 6 and 20, so this is 26. This will be 3 that plus 2, this is 22. 22 plus 6, 22 plus 12, so that will be, sorry, 20, this would be 22 plus 6, 12, so 22 plus 12, that would be 38. So this makes no sense because if you were at this point, okay, you were 3 cars over here, you would take 38 minutes, but if you switched over here, if you went over here, you would take 29.9 minutes. So you definitely go to A and B instead. So you would not, you would definitely cheat. Similarly over here, if 3 cars were traveling and 1 car decided to go through A and B instead, they'd save time. So instead of 33.8, they'd take only 30 minutes. So this also case is not going to happen. This case is also not going to happen because this one extra car here would decide to go via A and B, and this one extra car here would decide to go via A and B. Now let's consider the case of 0 and 4. If it's 0 and 4, that we have, this will be 23 plus 4 times this 9, so that is 15. So this is also, this is 38. Did I calculate this right then? When it's 3, that is 22. 22 plus 4 minus 3 minus 1, that is 2, 6, 12. 22 plus 12, so this is, sorry, 34, not 36. This is 22 plus 12, so that would be 34. So even in that case, this person would still prefer this because he'd save time. Similarly, this guy would, the extra car here would prefer the going via A and B. So because then he'd save 3.8 minutes. Similarly, the extra car that is over here would prefer going via A and B because he'd save time. Again, nobody would choose this because all of these would lose time. So essentially, if you think of it, so if all 4 cars are sent via A and B, one guy would definitely switch because he will now take only 26 minutes. So this will not be the distribution. Now it is 3-1. These guys are taking 33.8 and this is taking 26 minutes. But if one guy were to come to A and B, that person will take now only 30 minutes. And those guys, so he will definitely take it because he'll save 33.8 minutes. Now at 2-2, if either of these guys goes to the other side, so suppose the guy going from A and B goes to A and B, he'll take 34 minutes. So he'll definitely lose time. So he'll not do that. Similarly, if one of the guys from A and B goes to A and B, they'll take 33.38 minutes. So he'll not do that. So in this case, we see that nobody will switch because the minute they switch, they'll actually end up spending more time. For everybody else, you would actually save time. So I would switch if I were here, I'd switch to this. If I were here, I'd switch to this. So only in the middle case, when there are 2 cars each in each of the routes, would there be no switching. So the number of cars that would be asked to take the A and B route would be 2 cars. So the answer is 2. Now let's take a look at the second question. If all the cars follow the police orders, what is the difference in the travel time between the cars which take route A and B and the cars which take A and B? So all of them follow the orders, then the cars are taking, as we found this time, that is 29.9 and 30. So the difference is 30 minus 29.9, that is 0.1 minutes. So the difference between the two cars is 0.1 minutes. So let's see the third question. A new one-way road is built from M to N. Each car now has 3 possible routes to travel from A to B, that is AMB, ANB and AMNB. On the road from M to N, one car takes 7 minutes and each additional car increases the travel time per car by 1 minute. Assume that any car taking the AMNB route travels the AM portion at the same time as other cars taking the AMB route and the NB portion at the same time as other cars taking the ANB route. How many cars would the police department order to take the AMNB route so that it is not possible for any car to reduce its travel time by not following the order when the other cars follow the order? Assume that the police department would never order all the cars to take the same route. So now this is the case as such. Now let's go back to our drawing. So they are saying that there is an additional road over here, that is 7 plus what is the additional this? 7 minutes and each 1 minute. So this is 7 times x minus 1. So now if you see that our original calculations over here, I'll just draw them out again so that we have more information about how each of these guys will behave. So as we know that the original condition is 2, 2 and that case is 29.9 and 30. Now let's consider, would it make sense for somebody to switch in from that case? So we have AMB, ANB, AMNB. So I have the first, this is 2, 2 and we found in this case it is 29.9 and 30. Now suppose now if it is AMB, ANB and nobody goes from AMNB. So these are the values that we calculated earlier. Now suppose one car from AMB decides to go from AMNB instead. So that will be 1, 2 and 1. Now in that case, let's actually let me draw it over here so it won't save me some time. This is as 6 plus 8. Okay, let me draw it quickly over here. So this is 6 plus x minus 1 times 3, 6 plus x minus 1 times 3, 7 plus x minus 1, 20 plus x minus 1 and I think 20 plus x minus 1 times 0.9. So this is the equation as such. Now suppose somebody switches from AMB to AMNB. How much time would that take them? So they'll still do the AM part with the same guys. So that part would not change. So that would essentially be 6 plus 2 minus 1 times 3. So that will be 9 minutes for both of them. Now AMNB part, he'll be the only guy going from here. So this will be 7. And the NB part, he'll be, now there will be 3 people going from NB. So for 3 people, it will be 6 plus 2 times 3. So this will be 12. So, and for this guy, there's only one person going. So this will be plus 20. And for this guy, this will be 20. These are 2 people coming on A and B. So this is 21 plus, now there are 3 people going. So as I said, this will be 12. So these are 29, 33 and this is 16 plus this. So that is 28. So if you see from this guy's perspective, the 2 cars that were going in A and B, if he switched over to AMNB, he'd be saving 1.9 minutes. So he definitely switched to AMNB. So definitely it is not 220. Now let's see if both guys who are going going via AMB now switch to AMNB. If both guys switch to AMNB, now this is the not happen. This is 0, this is 2, this is 2. If both guys switch to AMNB, then what happens? This is again 9. This is 7 plus 1, that is now one more additional due to congestion, that is 8. Now 4 people are going through this. So if 4 people are going through this, this is 6 plus 9, that is 15. Now for this same 2 people are going, 21 and again 15. So this will be 36 and this will be 17 plus 15, that is 32. Now for this guy it is a losing proposition to switch to AMNB, because earlier it was taking him 29 minutes. So this guy over here, it was earlier taking him 29 minutes and now it will take him 32 minutes. So for him it doesn't make sense for him to switch. So he won't switch. So essentially we'll get that one guy will continue to take that route. So we'll have 1 over here. Now let's see if it makes sense from one guy from A and B to switch. So suppose it is 1, 1, 2. Now if it is 1, 1, 2, what would be the values as such? Now 1, 1, 2, as I said, this is this will again for A and M, between A and N. Now there are 3 people going, so that is 6 this, so that is 12 minutes for both of these guys. Between this now there are 2 people going, so that is 8 minutes, and over here now there are 3 people going, so 3 people is 6 plus 6 or 12, and over here this will be for this guy it is just 20, so this is 32, this is 32, and this guy it is 20 plus 12, this guy would also be 32 minutes. So as we see, all of them, this guy would definitely switch, because earlier he was taking 36 minutes, the guy over here, and now he'll take 32 minutes if he switches to AMNB. So he'll switch. The guy who was, this guy will take now 32 minutes. This guy will switch because he'll now take 36 minutes. What he used to spend 36 minutes, he'll now take 32 minutes. So the answer over here, this A, from this position, this guy will not go back, and this guy will not come to AMNB, and this guy will, let's see if both of these guys will switch. From A and B, does it make sense for all the guys from A and B to come to AMNB? So that is the situation where it is 1, 0 and 3. If it is 1, 0 and 3. So we consider the question that position where both people from A and B come over, and both people from A and B come over. So let's see when both people from A and B come over. So in this case, this guy would, since there are 4 people going from A to M, so that is 6 plus 9 as such, so that is 15 for all, plus there are, this guy will take 20, so this is 35, and for these guys it will be 6 plus 2, that's 9 each, plus again there are 4 people going, so there are 3 people going this route, so that is 3 plus sorry, this so 2 times 6, so this is 12. For this guy there's nobody else coming, so that is 35, and this is 24 plus this is 36. So this doesn't make sense, because if you were in this guy's place, if you were in this guy's place, there was one person over here. If he switched to A and B, he'd save 4 minutes. So it definitely there will be some switching. So this case is unviable, this case is unviable, this case is unviable, this case is unviable. So all of these guys, in all of these guys, they would switch just to save time. So from this case, this one guy from A and B would move to AMNB. From in this case, this guy from A and B, who is traveling taking 33 minutes, would move to AMNB, because then he'll take 32 minutes. From this case, you would move to like one person would move to AMB, because they will take 32 minutes. So from this case, you would not move anywhere, because if you move anywhere, you would actually end up taking more time. From this case, you would move to A and B, because you will take 32 minutes. So from all of this, you can see that the only viable case where nobody will switch is if the number of cars that go is 1 car from A and B, 1 car from A and B, and 2 cars from AMNB. So the answer to this question is, how many cars would they route through AMNB is 2 cars. Now let's take a look at the last question of the set. The same setup, if all the cars follow the police order, what is the minimum travel time from A to B? The minimum travel time that we saw over here is 32 minutes. All cars, once they follow those orders, all cars take 32 minutes. So the answer to this question is 32 minutes. So as we saw, once we wrote down all the configurations, it became pretty easy to do. The thing over here is that you should quickly understand how moving one thing would affect the entire network as such. If you understood that, and once you were able to comfortably write in that table format, this question would not be difficult. However, this question was a lengthy question. This would take you 15 minutes of time to do. So this would have been a slightly more difficult, time-consuming question, but not a difficult question as such. So this is how we solve DILR sets based on roots and networks and on other basic concepts. So through these series, we have solved all the DILR sets that are there in slot 1. We will shortly be putting up videos for slot 2 as well. Our endeavor through these videos is basically to make all of our students comfortable in solving all DILR sets. So the more sets you solve, the more comfortable you will get solving DILR sets. So I would encourage you to keep solving more DILR sets, get more practice, as much practice as you can, and thank you for tuning in. Please hit the bell icon to subscribe to our videos. Also check out our description box because we have given a lot of links to the free stuff that we have put in. We have a free mock, we have a lot of free sectional tests, free topic tests as such. So please do check out our description box to see all the free stuff available on Kraku. Thank you.